When doing a chemical analysis, it is not enough to just know the empirical formula for a compound. You could have two compounds with the same empirical formula, and both of those compounds could do very different things. So the last step of an analysis is to determine what the molecular formula is of a compound. For example, let's say we have the empirical formula CH2O. So here's an empirical formula, and I need to find the molecular formula. Well, there's another piece of information I need. I need the molecular formula's molar mass. And there are a few techniques that can be used to find this, but I'm just going to give you it. So the molar mass of the molecular formula, and in this example it's going to be 120.12 grams per mole. And remember that the formula you're given is the empirical formula. So in solving for what the molecular formula is, it may be useful to figure out, well, maybe I already have the molecular formula. It's possible. So how would I go about doing that? Well, we have the molar mass of the molecular formula, so what we have to do first is find the molar mass of the empirical formula. Find the molar mass of the empirical formula. And we do it, in this case, we get the molar mass of the empirical to be 30.02 grams per mole. So right away we see that the molar mass of the empirical formula does not equal the molar mass of the molecular formula, meaning we don't have it already. So step 2 is going to have two parts. First, if the molar masses of the molecular and empirical formulas are the same, the molecular formula is the empirical formula. The second part, and the more likely part, is if they are different, divide the molecular molar mass by the empirical molar mass. So let's do that. We're going to divide it. Basically, this is to see how many times bigger the molecular formula is than the empirical formula. So we start, the molecular molar mass is 120.12. We're going to divide that by the empirical molar mass. And when we do this, we get 4. And when you do molecular formulas, usually this number is going to be a whole number or very, very close, meaning 3.9 or 4.0, 4.1. Those are pretty much the same thing as 4. That's just a significant figure rounding error. But in this case, we do get 4 when we divide the two. And now we are on to the last step. So step 3. Multiply the quotient. That's just the number we get when we divide the two numbers, by each subscript in the empirical formula to get the molecular formula. Let's do that. So we have the number 4. So I'll rewrite this compound actually. So the empirical is C1H2O. And the number I have to multiply by is 4. So I'll write times 4 times 4 times 4. And I end up with C4H8O4. And this would be my molecular formula. And that's it. So find the molar masses, divide them, and then multiply the empirical subscripts by the quotient that you get after dividing. And this would be our final answer.